Hey, let's look at some blocks on a ramp that's being affected by friction. That seems simple enough. Okay, so let's just look at this picture. We have this 80 Newton block on a ramp. So you need to draw this thing out. So first of all, draw a line straight down. That's going to be the weight. And it says 80 newtons already. So 80 newtons is the weight. Right? If you're wondering, 8 kilograms would be the mass. Again, if you're not in my class, I just use 10. This is WMG, right? I used to use 10 as gravity, so that's where we're getting 8 and 80. All right, now we're going to go and break this down into a perpendicular to the ramp and a parallel to the ramp. And again, we want to be in a right triangle and usable distances and usable directions. So anything that is parallel to the ramp is usable, and perpendicular will be used for something here in a little bit. All right, we have to find the sides for that now. The angle of this, of course, is going to be 20. It's always going to be the same as whatever this is down here. All right, so we're going to plug this into an equation. Oops, come back up here. And we'll see that the 80 times the cosine, because this is the adjacent side, of 20 is going to be equal to that perpendicular side. And P is going to be equal to 80 times the sine of 20. All right, so you can find those sides pretty easy with that. Okay. Now, what we're going to have to do is we're going to have to try to find out what the other forces applied on this thing are. Looks like I'm having a family timeout, so just a second. That's not quiet, is it? Okay, so let's figure this out. I put the numbers in while I was going. Guys. All right. And so what we're going to do next is we're going to put in our normal force. Our normal force is always perpendicular to the ramp, pushing back up. So the normal force is just another way of saying how much the surface is pushing back up perpendicular. So this is our normal force. And our normal force is going to be equal and opposite to our perpendicular force. So it's going to be 75.2 newtons also. Okay, let's highlight that. All right, now, the rest of this question says, what will cause the block to slide up the plane at a constant velocity? Slide up at a constant velocity. So constant velocity means that it's moving. So we're going to use, we're not going to use static friction, we're going to use kinetic friction for this. So we're going to use the coefficient of kinetic friction right here. If it asked what force would take to make it start sliding, then we'd have to use the static. But they're saying what would keep it sliding at a constant velocity. So we're going to use that. Now, friction. Friction is fun, right? So friction equals the coefficient of friction times that normal force that we just found. So if we're trying to find the friction, it's going to be 0.15 times our normal force, which was 75.2. All right, so how easy that was. Okay, now let's see here. 0.15 times 75.2 equals, I got 11.28. Let's count that, 11.3 newtons. So there's my friction force. All right, now, we're going up the ramp, right? So that means friction is going to go down the ramp. So we have friction pushing here, well, holding back, right? And then we also have that force of the parallel force pushing there too, which we had in blue, so I'll draw it in blue. So we had that parallel force there also. So our force that is pulled up the ramp must be equal and opposite to the friction force plus the parallel force. I'll say that one more time. The force going up the ramp, to make it go up the ramp at a constant velocity, that means it has to be equal and opposite to the friction force and the parallel force that are going down. So we're going to have 11.3 newtons plus 27.4 newtons, and that's going to be equal to 38.7 newtons. If my math is wrong on that, and you find that out later because you punch into a calculator, I didn't use a calculator, so just forgive me for that. But that's what I get right there. And that's the force it takes to keep moving up the ramp. Now, if we're going to find out how the force to make it start moving, we would have just used this number right here, and we would have done the same exact thing. We would have said 0.25 times 752, or 75.2. Calculator. So 0.25 times 75.2 equals 18.8. So to overcome static friction, you'd have to take 18.8 newtons plus the 27.4 newtons just to get it started moving up that hill, right? And I won't even calculate that out because it doesn't ask for it. Okay, I hope that helps, and have a great